Hello everyone, today we are looking at an O-level trigonometry question. And I like this question because it really combines not just trigonometry, but also it combines it with quadratic equations and a bit of showing and derivation. So I think it's worth taking a look. So let's jump right in. And over here it says in the diagram below ABD and ACE are straight lines. So that tells me ABD is a straight line. That means it's not a line and then bend. No, this is 180 degrees. And ACE, straight lines. Cool. BAC, angle BAC is theta, and that is this angle, BAC. It is theta over here. And BD is 12 cm. CE, 4 cm. And AB, x cm. And AC is 2x minus 5 cm. So just because it's algebra, you can see x and 2x minus 5, doesn't mean it's a difficult question. We can just apply what we know to find out what we don't know. So let's look at part A. Show that area of triangle ABC over area of triangle ADE equals to this on the right hand side. Now it's very daunting, it's very scary to look at this. So maybe let's start here. Can we find the area of the triangle? Then we think of the formulas that we know when it comes to area of a triangle for a triangle, and we know that the area can be half times base times height, or we know that the area can be half AB sine C, and I just wrote a capital C that way, so really that's for something like this, for a triangle like this. So half times A, one side of the triangle, times B, the other side of the triangle, and then the angle in between. This has to be an angle that's in between the two sides that you chose. And if you see here, we want area of triangle ABC, and ABC, this is the triangle. So maybe it's easier if we just highlight that. Do we know two sides and an angle in between? Yes, we do. Two sides and the angle in between. And it is convenient to see that on the right-hand side, it doesn't ask us to express it in terms of x or numbers. It actually just gives us AB times AC. So we can actually just use that. Area of triangle ABC is half times AB times AC times sine of the angle in between. Right? And then area of triangle ADE, so let's just highlight ADE over here. And do we know the two sides? Actually, whether you know it or not, because they're telling you, you can express it in terms of the alphabets they give. So AD, so really the area of triangle ADE is half times AD, which is, well, you can just write it as AD, and AE, and sine the angle in between, which is also theta. And immediately, what you can see right now is that the halves do cancel out, the sine thetas do cancel out, and what are we left with? We are left with AB times AC over AD times AE. There you go. You didn't know you would get here at first, but simply from applying what you knew over here, you managed to get the right answer. And then, of course, you end off with shown. Great. Now let's move on to the next part. It is given that this relationship, area of ABC, a triangle ABC, over area of triangle ADE is 1/3. And they ask you to use your result in part A to form an equation in X. So use your result in part A, and so just compare quickly this relationship and this relationship. They're the same. It's the same thing, and so you've already solved some of it. So actually you've already shown that it's actually equal to AB times AC over AD times AE, right? This is actually this. You've already shown in part A. And this, now they tell you, is equal to 1/3. Now you may see, oh, but what about all these x thing? I don't have any x here. But wait. Let's try to express AB, AC, AD, and AE in terms of x. So what is AB? So we'll go back here. AB is x. You can see from the diagram. right? So AB is simply x, and then AC is 2x minus 5. AD is 12 plus x. You can take a look here. AD is 12 plus x, or x plus 12, AD. And so we can just write that down, x plus 12 over here, multiplied by AE. And what is AE? AE is 2x minus 5 plus 4. So let's go there. 2x minus 5 plus 4. And they tell me this is equal to 1/3. Right. So everything on the left-hand side became this when I express it in terms of x. And everything on the right-hand side, 1/3, didn't change. There you go. Now, what we have to do is simply expand and simplify. So let's do that. So let's just expand it. So x times 2x equals to 2x squared minus 5x. And then let's simplify that. So that actually is x plus 12 still. 2x minus 5 plus 4, that's actually minus 1, and this is 1/3. So I'm just going to use the space. I'm going to use the space over here. Okay, and so let's just simplify. Actually, over here, what we can do is we can cross multiply. And that should give us 3 times 2x squared minus 5x equals to the whole chunk over there, 1 times x plus 12 times 2x minus 1. There you go. You can see we're getting closer and closer to what we want. And so let's just continue to simplify. And so let's continue to expand everything. And so this gives me 2x squared minus x plus 24x minus 12. And then we just continue simplifying. 6x squared minus 15x equals to 2x squared. Let's combine the like terms. So that's 23x minus 12. Now we see that it's a 0 on the right hand side. So let's just move everything to one side. So that gives me 4x squared minus 38x plus 12 equals to 0. And you see, we didn't get exactly what we wanted, but because it's a 0 on the right hand side, what we can do, we can say, okay, we have a common factor of 2. Everything can be divided by 2, so let's just divide the whole thing by 2, and divide this by 2 as well. When you divide by 2, 4x squared becomes 2x squared, and 38x becomes, or negative 38x becomes negative 19x, and 12 becomes 6. And 0 divided by 2 gives you back 0 still. And voila, you have shown whatever they've asked you to show. So I'll zoom out for you to take a look at the whole working. All right, so where we go now, solve this equation giving your answer correct to 2 decimal places. So this is a quadratic equations part of it. And so I like to start by just writing down the equation again. And there are a few ways that we know how to solve quadratic equations. And I think the most straightforward way, especially if the question doesn't dictate the way or require you to use a certain way, let's just use the quadratic formula, right? The quadratic formula says that x equals to negative b plus minus square root b squared minus 4ac over 2a. And it's not just for any equation. This is especially for an equation whereby it looks like this. I'm just going to write in the different alphabets. Ax squared plus bx plus c, and this whole thing must equal to 0. For such an equation, this is true, where a, b, and c are the coefficients, right? So in this case, what is a? You can see that a is 2. So yes, a has to be the number in front of the x squared term, so it is 2. And b has to be the number in front of the x term, and in this case, always take the sign with it, so it's negative 19. And c is just this number, and so to take the sign with it, so positive 6. And then now does it look like ax squared plus bx plus c equals to 0? Yes, so we can just apply the formula straight away. So x equals to negative. When you sub it in, put a bracket. Negative b. B itself has a negative sign. Negative b plus minus bracket. B squared minus 4 AC over 2A. If you key everything to your calculator, you will see that you get x, okay, let me write this way, 9.17 or 0.33. So you can say x equals 9.17 or 0.33. Yep. There you go. Okay, for the last part, state with the reason which of these solutions do not apply or does not apply to triangle ABC. And so let's look back at triangle ABC. Okay, and let's see which one doesn't work. So when it doesn't work, really the easiest way to look at it is just substitute in some of the values. So let's say x is 9.17, and if x was 9, let me just write it here, x can be 9.17 or 0.33. And if x was 9.17, then what would 2x minus 5 be? 2x minus 5 would be 13.34. Okay, that sounds reasonable. That sounds okay. So let's just see what we get if we sub 0.33 in. What would 2x minus 5 be? And 2x minus 5 would be negative 4.34. Negative, then you ask yourself, can a length be negative? No. In that case, there you go, there you have your answer. So 0.33 does not apply, so you can say that x equals to 0.33 does not apply to triangle ABC, as 2x minus 5 will be negative. There you go. So this is the full question. Ta-da!